Sum and difference of sine and tangent identities. And as you see here, there is some identities that would be really helpful to memorize for the sine and the tangent. Okay, so let's solve the first problem here. It says find the following sum in the terms of pi. All right, so what we're going to do is basic math here. We have pi sevenths plus pi sixths, and we want to know what is the sum of it. Well, in order to add fractions, we have to have a least common denominator. And in this case, 7 is prime. So it's just easier to say, okay, if I multiply 7 by 6 and then 6 by 7, then I'm going to get what I need in the denominator that's going to be identical. So 7 times 6 is 42, plus 6 times 7 is 42. So now I have a common denominator. I have 6 pi and 7 pi, and I can rewrite this as 6 pi plus 7 pi all over that 42. And when I add that up, I get 13 pi 42s. And that is my answer. All right, let's do number 2. It says express the given angles as alpha plus beta, where sine alpha and sine beta are known exactly at 75 degrees. All right, so what we need to do is find the sum of these where they add up to 75 degrees. Well, we can look at 65 plus 10, we know is 75. 55 plus 20, 75. 40 plus 35, 75. And we know this is 75 as well. However, when we look at it on the unit circle, we can find the angles exactly. We know 30, 45, 60, 90, 120, and so on. In this case here, the best option is going to be A. And if we wanted to, what we could do is come up here to the top where we have the formulas, and we can pull our sum and we can plug in and then see what it gives us in the end. That's another way to check to see which one's the best choice. Okay. And we just, like I said, we plug in. So we picked A, so alpha was 30 degrees and beta is 45. So plug it in one of those formulas and check it out. All right. So number 3 says use the appropriate identities to find the exact value of the following expression with sine 11 pi 12ths. Since we do not know exactly value of the sine 11 pi 12ths, then we will need to write it in the format of alpha plus beta in order to figure it out. Okay, whose sine and cosine are known exactly. So when we go to our unit circle, we're going to find points on there that we can determine what okay, let me say this right. We can go to the unit circle and pick the exact points and then use those numbers. So let's go to the unit circle and let's pick for alpha. Let's let alpha be 3 pi 4ths. And this is what we do. You pick it and plug it in and solve. So now that I know this here, I'm going to solve for beta. So in order to do that, I need to subtract the 3 pi 4ths from both sides. And when I do that, I notice that I need to have at least common denominator. In this case, it would be 12. So 3 times 3 over here. So now beta is equal to 11 pi 12ths minus 3 times 3 is 9 pi over 12. We can rewrite that as 11 pi minus 9 pi all over 12. And that would give me my 2 pi 12ths. And of course, we're going to reduce that down as pi 6. And that would be our answer for that part. So the next part is, now that we know what beta and alpha is, let's take our formulas. So we got, let's just rewrite this right quick. So we know that sine of beta, which we set, our alpha, 3 pi 4ths plus beta pi 6. We're going to plug it into the formula that we got at the top, or the identity. And all right, now let's solve for it. Well, when you go to the unit circle, sine of 3 pi, of course, is square root of 2 halves, times the cosine of pi 6, which is the square root of 3 halves. And we're going to add it to cosine of 3 pi, for us, is a negative square root of 2 halves. And we're going to multiply it by the sine pi of 6, and that's a half. Now let's just clean it up. Square root of 2 times square root of 3 is square root of 6 over 4. Negative times positive is negative. Square root of 2 times 1 over 4. And now we can clean this up just a little bit better. And we can say square root of 6 minus square root of 2 all over 4. And it asks for the exact values. If it asks us for appropriate approximation and round to the nearest up, then you would put it in your calculator and get a rounded number. So be sure and read what it asks us for. All right, the next one says use a sum or difference identity to find the exact value of the expression of tangent 75 degrees. All right, so when I go to the unit circle, I'm going to pick, I'm going to let 30 degrees, alpha be 30 degrees, and I'm going to let beta be 45 degrees. Okay, now that we use the identity of it, let's go pick it, plug in. Okay, so once we're done plugging in, now we're going to clean it up. Okay, so once we do that, what do we know? Well, we know that tangent of 30 degrees is the square root of 3 over 3. And we're going to add it to the tangent of 45 degrees, which is 1. All divided by 1 minus the tangent of 30 degrees is square root of 3 over 3 times that 1 for tangent of 45 degrees. And we're just going to clean this up. Well, in order to add the square root of 3 halves plus 1, or we could, let's just clean first things first. Let's just write it in a format where it's just easier to read. Okay, and I'm going to go ahead and multiply that 1. So this gives me this. All right, so now, in order for me to add or clean it up, I need to find a common denominator. In this case, I'll multiply top and bottom by 3. So now I got square root of 3 plus 3 over 3 divided by, and I got to do the same thing here because the denominator is 3 and 1. So now I got 3 minus the square root of 3 over 3. And now I'm going to keep the first term because we're dividing with fractions, change the operation, and flip the second. So now that I've done that, I noticed that my 3's reduce here. And I'm left with square root of 3 plus 3 over 3 minus square root of 3. Now, if it asks us just for the exact value, then we're going to leave it in this format. It may ask you to simplify it a little bit better. If it does and it asks you to simplify more, then that means we need to multiply by the conjugate, meaning that we need the denominator to get rid of that root. So since it's a minus here, I'm going to put plus, and then I'm going to do the same to the top. And now this is just if it asks you to simplify more, okay? And this should be correct here, but sometimes it will ask you to simplify more. So now I got the square root of 3 times 3 plus the 3 times the square root of 3 all over. Oh yeah, we got to do the whole full method. You know? Okay, so, and now I got the square root of 3 times the square root of 3. Okay, so I did this. Now let's do the 3 times the 3, which is 9. Just go ahead because I'm out of paper room here. which is 9. And then 3 times the square root of 3. All over 3 times 3 is 9 minus 3 squared times 3 square root is 3. So now I'll clean it up. I got 3 square root of 3. 3, because square root square becomes 1 and leaves me with 3. So 3 plus 9 is 12. And then I got this other square root of 3 square root of 3 here. So I can add those two together. Let me just highlight it to save some space here. Let's put these two together. Remember, this reduces down to 3, and so I can add it to the 9. So this here is this plus this is 6 square root of 3 all over 9 minus 3 is 6. Now let's reduce. It all reduces by 6, right? 6 goes into itself. Oops, let me get it. Goes into itself once, goes into this once, and goes into 12 2 times. Now that I've done that, I got square root of 3 plus 2. And that would be my final answer. That's if they want you to simplify more, okay? So this is basic math. But if it just says exact form and that's it, this would be it. All right. So let's do example 5. Example 5 says simplify the expression by using the appropriate identities. Do not use a calculator. All right, so now I'm going to recognize what is my alpha. Well, my alpha here is 65 degrees. My beta is 25 degrees. And let's plug it in. So I got the sine of alpha plus beta is equal to the sine of 65 degrees plus 25 degrees, which gives me sine of 90 degrees. And when I go to the unit circle, sine of 90 degrees is 1. So that's my answer. Okay. Number 6, find the exact value of sine alpha minus beta. When you know that alpha is a negative 8, or sine alpha is a negative 8/17, and the sine of beta or cosine of beta is a negative 24/5. All right, so now that we know that much, we'll go grab the identity that we're going to work with. And also, let's just write this down. So, it says beta is in quadrant 2, alpha is in quadrant 3. So this is important information as well. So let's use the sine identity. It said that we have sine of alpha minus beta. Well, we know that it's going to be sine alpha cosine beta minus sine, switch that, be cosine alpha, because we want to keep the alpha and betas in the right order, sine beta. All right. So now that I know what the sine alpha is, we can do some extra work to figure out what the cosine of alpha is, because we don't know what cosine of alpha is. We just know what sine of alpha, and then we're going to do the same for beta. So let's solve for that. Well, when I do that, I'm going to use the Pythagorean identity. So what I'm going to do is I'm going to plug in right here the negative 8/17 for the sine. And we're going to go ahead and square it. It gives me 64 2/89. And then I want to get cosine by itself. So I'm going to subtract that from both sides. So now I got cosine squared of alpha is equal to, well, I got 1 minus that. Well, I need to multiply by the least common denominator. So now I got 289 minus 64 all over 289. So now I got cosine squared alpha is equal to 225 over 289. And now I'm going to take the square root of both sides because I want just cosine. I don't want the cosine squared. That means I'm going to get a plus or minus. All right. So now I got cosine of alpha is equal to, and I take the square root plus or minus the 15th, 17th. But it said alpha was in the third quadrant and cosine is negative in third quadrant. So I'm going to go ahead and erase this positive, and that would be our answer for the cosine of alpha because it fell in the third quadrant. Now, let's find the beta. Well, we don't know what sine beta is, so let's go find it. So we're going to do the same thing. I got this sine. Oops, let's see if I can draw a line under here, kind of make it easier to follow. All right, so now I'm looking for sine beta. So we're going to use the identity again. Sine squared beta plus cosine squared beta is equal to 1. And I know what the cosine beta is. So I got sine squared beta plus negative 24/25 is equal to 1. We're going to square that. When I square that, I get sine squared beta plus 576/625 minus equals negative, or excuse me, equals 1. I'm jumping ahead because we're going to subtract that from both sides because we want sine by itself. So now let's take that sine squared beta, set it equal to, that means I need to subtract this from both sides. So I got 1 minus 576/289. Oh, excuse me. 289s I pulled from the number above it, 6/25. Okay, so we need a common denominator. So I got to multiply that 1 by the common denominator, top and bottom. So now I got 6/25 minus 576 all divided by 6/25. And that gives me 49/6/25. So now I need the sine squared, or I need the sine and it's squared. So I'm going to take the square root of both sides. Gives me a plus or minus. Okay, so now I have sine beta is equal to plus or minus 7/25. Now beta fell in the second quadrant, and in the second quadrant, sine is positive. So we're going to get rid of the negative. So I can just go ahead and remove both of them because we know what that is. So now I know what the sine beta is. So we're good. Now we can plug everything into our formula, our identity. All right, let's scroll just a little bit. So our identity is going to be sine alpha minus beta is equal to the sine of alpha. When we said sine of alpha is going to be negative 8/17 times the cosine of beta, and we said that was negative 24/25. And then we're going to subtract it from cosine of alpha, which we just solved as a negative 15/17 times the sine of alpha or beta. I got cosine of alpha now times the sine of beta. All right. So what do I know? We don't need to write the sine and cosine anymore here, right? Because that's what it is. Sine of beta is that. Cosine is that. So some of you may want to do that and then mark it out. You can. Some may not want to even write that down. Don't want to confuse yourself. That's fine. I mean, if it's easier, whichever way works for you is the best way to set it up. Just make sure that you don't keep these here if you choose to write it that way. I only did it because I just wanted to show you where I was pulling my numbers from. So now what I'm going to do is basic multiplication. We multiply straight across. So I got negative times negative, 8 times 24. So negative times negative is positive, and 8 times 24 is 192. 17 times 25 gives me 4/25. And then I got a negative here. However, I got a negative times positive. So I got that negative that's going to make this a positive, right? See, negative times negative. And then there's a positive here, so that didn't change. So I got 15 times 7, 21. Amen. 15 times 7, double check my math. That's not 21. So 15 times 7 is 105. And you can double check. It never hurts to double check on any of the numbers. All right, so now we got 17 times 25, and that's 425 again. So that worked out great. So now we're going to add, since it's common denominator. So I got 192 plus 105, it's 297, divided by 4/25. And you want to double check to make sure if it reduces, because if you can reduce it, reduce it. It doesn't always reduce. But one way to let you know that this one did not reduce is because this number ended in a 7 and this one ended in a 5. If it ends in a 5 or a 0, they both need to end in a 5 or 0, or it's not going to reduce. So that is my final answer for this one. All right, so now let's do our last problem. So we're going to write the following expression as a function of alpha alone, tangent 7 pi force plus alpha. All right, so let's go grab our identity. We got tangent of 7 pi force plus the alpha. All they did is alpha plus beta, but they said, well, let's let alpha be the 7 pi force and let's let beta be alpha this time. You know, it's just recognizing the formula or the identity. So now let's plug in what we know. We got tangent 7 pi force minus tangent of alpha over 1 plus the tangent 7 pi force times tangent of alpha. So tangent 7 pi force is going to be a -1. So now I have this, and I'm just going to clean it up a little bit. All right. So what happens here? This is my final answer. Right here is my final answer. It doesn't reduce. If this was a positive, we would have had an answer of 1. Since that's not positive, it's not identical, and you can't pull it out and make it identical, because if you pull a negative out here, you got to pull it out here and here, and it doesn't work. So to give us exact, so that's our answer.